Yet another salt-tolerant species is frostweed. This plant flowers late into the summer, hence its name, typically seen blooming until first frost. Polygala, or procession flower, is another very interesting addition to a coastal green roof and grows well with respect to drought and is extremely salt tolerant. Some of the more brilliant late summer blooming flowers like Carphephorous and Liatris are also salt and drought tolerant, grow amongst the dunes and in the coastal strand, provide plenty of color for the coastal green roof during the late summer season. Salt and pepper plant is yet another very interesting plant growing in the coastal strand and along the shady dune areas. Wood germander, although somewhat of a weedy plant, has a brilliant display of late summer, early fall flowers, providing pollen and nectar to numerous insects, butterflies, and bees. The legumes are a very important coastal strand and seashore plant family, fixing nitrogen, growing well with respect to drought, and very salt tolerant. In fact, some of the legumes, such as the thicket bean, are an important food source historically. A deciduous vine, thicket bean, will provide interesting texture and color to a coastal green roof during the late spring and early summer. Yellow leaf cup is a salt and drought tolerant aster species suitable for coastal green roofs, one preferring a little bit of shade. Of course, the golden asters are very hardy, extremely drought tolerant, and very well suited for coastal green roof plant applications. I think the golden asters produce some of the most brilliant and stunning arrays of flowers found anywhere along the coast. Salt marsh aster that are growing in our project area is one of those plants requiring moist soils. Poorman's patches, however, grows across the dunes and throughout the coastal strand, is extremely drought and salt tolerant, and provides amazing late summer color. Betony is considered to be a weed by many. However, Betony has proven herself throughout the winter to provide evergreen cover and to provide brilliant displays of light purple flowers. Garbaria heterophylla is one of those unexpected surprises that one occasionally sees growing across the coastal strand or dune area. This plant is also very drought tolerant, salt tolerant, and well suited to coastal green roof applications. Believe it or not, common dog fennel has some of the most glorious late summer, early fall white blooms found along the dune area. A hardy plant, dog fennel should be considered in any coastal green roof application. Asclepiases, or the milkweeds, are yet another drought and salt tolerant flowering plant that can be found growing on our project site in the coastal strand and along the dunes. There are many different types of milkweeds, and one of my favorites is the butterfly weed Asclepias tuberosa. All of the milkweeds provide important wildlife function. You won't find another plant capable of attracting butterflies en masse than saltbush. Saltbush is an interesting structure plant that is deciduous, yet should be considered on just about any coastal green roof application planting scheme. Southern Gaura is a diminutive yet very salt and drought tolerant, colorful plant that can be used and interspersed amongst other plants on the coastal green roof. Pokeweed is one of those plants that you either love or hate. Undoubtedly, this plant has brilliant displays of bright pink and purple color with broad green leaves and grows well in dune conditions. All Chrysopsis species are considered the flower of the state of Florida, great green roof plants. Ageratina is another one of those smaller plants, but important in the coastal strand and applicable for green roof design. One of my favorite late summer and early winter plants is the climbing asters. These plants produce copious amounts of flowers and are extremely reliable to bloom year after year. Very drought tolerant, they do like moist soils. Yet climbing aster will do well in dry areas. Climbing aster can be planted on green roofs around air conditioning condensate drains. Hypericum species are common evergreen flowering plants found in the coastal strand and growing along dunes, and are perfect plants for coastal green roofs. Another extremely fascinating plant found growing in the coastal strand and applicable for coastal green roofs is Honeycomb Head, a member of the Aster family. With C4 photosynthesis capabilities, this plant is extremely drought tolerant and provides a good windbreak. Sandweed, again, is a Hypericum, an evergreen species, and does well on green roofs along the coast. Echinacea, or coneflower, is another C4 species, member of the Aster family, that makes a good windbreak hedge and is very salt and drought tolerant. Dewberry is an interesting addition to any coastal green roof. This plant species is quite salt tolerant, very drought tolerant, and provides food to a variety of different wildlife types. One of the first plants I ever used on coastal green roofs was the leerleaf sage. The leaves are typically evergreen, and the plant offers beautiful springtime lavender colored flowers, a great addition to any coastal green roof planting scheme. Purslane is also extremely drought tolerant, one of the first plants found along the shoreline growing atop dunes. Very salt tolerant, very drought tolerant, and interesting coastal green roof plant. Once you complete a full annual cycle of ginkgo walks or site biological botanical assessments, then you can start developing your plant list and your plant bloom rows. This site plant bloom rows is important to coastal green roof design because it allows the designer an insight into what color schemes are available throughout the different seasons of the year. So by tracking what plants are blooming when throughout the different months of the year and the color of those blooms, the color rows can be created. And not only is it beneficial to the green roof designer, but also to the client in visualizing what types of colors the green roof will offer during the various seasons. Now let's review a little bit of fundamental botany relevant to coastal green roofs. There are basically three types of photosynthetic processes: C3, C4, and CAM. First, let's take a look at C3 photosynthetic processes. In C3 plants, photosynthesis occurs very near the leaf's surface in chloroplasts. In C3 plants, photosynthesis occurs rapidly, uses a lot of water, and is extremely subject to quick desiccation. C3 plants grow fast. However, C3 plants can quickly be desiccated by strong winds or overbearing sunlight and can keel over and die. C3 plants do best where there are high levels of carbon dioxide, such as urban areas. And on a green roof, C3 plants are important because they provide plenty of cover quickly, yet they must also be protected from the elements and are therefore usually found in a more protected zone on the roof. Unlike C3 plants, C4 plants are more drought tolerant. C4 plants break the photosynthetic process down spatially into two separate areas, one embedded deeply in the leaf to protect the sugars and the chemicals from rapid water desiccation through winds and extreme heat. Some of the best known C4 plants include the Poaceae, the grasses, and the aster family. Because photosynthesis is embedded in the plant and protected from desiccation, C4 plants are more drought tolerant and can be used as windbreaks on a green roof. C4 plants play a very important role in our world's ecosystem. Unfortunately, as carbon dioxide levels increase, pollution and smog have detrimental effects on C4 plants. C4 plants can be seen growing where C3 plants will not grow due to overly desiccating winds and other limiting environmental factors. Coastal dune areas buffeted by desiccating winds show C4 plants' abilities to survive in areas that C3 plants would not survive in. C4 plants make great windbreaks for green roofs. In addition to the Asteraceae and grass family, there are other C4 plants. Understanding C4 photosynthesis is critical to good coastal green roof design. The third type of photosynthesis found in plants is called CAM. CAM, or CAM, stands for crassulacean acid metabolism. A CAM plant differs from C3 and C4 photosynthesis by closing their stomata during the day when water desiccation could occur and opening the stomata only at night. CAM plants isolate photosynthesis on a temporal basis rather than a spatial basis as in C4 metabolisms. The importance of CAM metabolism is that by stomata remaining closed during the day, plants can survive for extremely long periods of time without water. CAM plants typically include many of the cactus, agave, yucca, bromeliads, and orchids. CAM plants make excellent primary perimeter windbreaks for green roofs. Understanding the relationship of C3, C4, and CAM photosynthesis is an important aspect of coastal green roof design. Now, let's take a look at a coastal green roof design model that we utilize on a frequent basis. Organizing data used as a basis for making green roof design decisions is very important. Initially, on our model, we will take a look at generic project information, including name, contact information, addresses, etc. It is important to identify and document the existing land use categories on a site. Additionally, it's just as important to quantify and identify all of the native species that grow well on a project site. Early on in the model, we list all the plants that we find on site based on our ginkgo walks and botanical surveys. Using the genus and species information we've gathered during our ginkgo walks over the course of a year, we can formulate a site flower bloom rose. The site flower bloom rose provides us with an annual look at plant activity. Importantly, the three primary design variables that we will work with on coastal green roofs are salt scorch, wind effects, and light availability. The coastal green roof model requires that one break a roof section down into a grid. Within the grid, each polygon relates to the intensity of wind impacts, the availability of light, and the intensity of salt scorching potential. To most, sunlight availability is obviously an important design principle. But let's look closer at what wind can do and how it can impact green roofs. Sometimes I consider wind to be a hidden impact for green roofs. Barely noticeable breezes of 2 to 3 meters per second can quickly desiccate or overcome the vascular system of a green roof planting and cause injury to the plants. It is crucial for the green roof plant designer to understand project site wind profiles. Oftentimes, to the casual observer, it will appear as though there are very few winds buffeting a project site, when in fact, as we have here in the video, there are winds in excess of 3 meters per second. A 3 meter per second wind can quickly overcome a plant's vascular system. If you don't have an anemometer, no problem. You can go to NOAA's website and other great climatic information websites that provide wind details for cities across the United States and across the world. In addition to desiccating effects, winds can actually affect root architecture and the structure of the plants. One of the reasons that we work with three-dimensional matrices on coastal green roofs is the ability for plant roots to grow out and anchor themselves to the web of material. Typically on a coastal green roof, a three-dimensional web that's permanently anchored to the structure provides a platform for plants to anchor themselves to. Parapets are the best structural answer to windbreaks on a coastal green roof. However, where parapets are unavailable or the green roof is sloped, then the use of CAM or C4 plants may be substituted, these plants adequately breaking wind across a green roof. Understanding both light availability and wind direction across a coastal green roof is an important component of a successful green roof planting model. Transposing wind directional data and light availability onto the roof grid allows the designer to identify areas that may be problematic with respect to C3 plant placement, and instead the designer may use a C4 or CAM plant as a windbreak. Salt impacts can be hazardous to plants. There are many salt-tolerant plant charts available on the web. However, the very best method of determining the severity of salt spray is through field excursions, the ginkgo walks, and botanical surveys. These photographs illustrate how salt spray can damage a plant. Notice the salt spray damage occurs on the windward side of the plant. Halophytes or salt-tolerant plants, such as some of the seashore grasses, can serve as both windbreaks and salt breaks. Although there are, again, many web resources that define what plants are best suited for salt-impacted environments, we found that the ginkgo walks and site reconnaissance will ultimately reveal more important information for the green roof design. There are also a handful of other important design factors we call secondary design factors that impact the layout of a coastal green roof. One, for instance, relates to plants. During our ginkgo walks and botanical survey, we identified many plants that do grow very well in the coastal strand and up in the dunes. However, hidden amongst these plants sometimes are important hydrological factors such as groundwater levels. Some plants may appear to be drought tolerant yet require quite moist soils. Just because a plant grows in a dune does not mean that it is necessarily drought tolerant. Many times plant root architecture will extend deep into the soil media in an attempt to find water. And some of these plants, such as the oxeye daisy, are very dependent on a high water table or moist soils and may not do well on the green roof. Some coreopsis, such as the Coreopsis leavenworthii, also require a level of moist soils. During one rather large recent coastal green roof design, the landscaper wanted to use the oxeye daisy, thinking that it was very drought tolerant because it grew on the dunes, not knowing that it's listed as a FAC wet or obligate plant by the U.S. Army Corps of Engineers. Same way with elderberry. Allelopathic influences can also greatly impact a coastal green roof. It's important to consider what plants are growing around your proposed roof platform. Within the coastal dune ecosystem, there are some tree species that possess leaf litter which can be toxic to emerging green roof plants. Plants such as pine trees drop smothering pine needles, cypress needles have very allelopathic toxic effects, and it's important for the green roof designer to identify adjacent trees and those species that may impede green roof growth. The coastal green roof project designer can then take information pertaining to incompatible species and design the roof layout accordingly. The more pertinent information that can be overlaid on the site layout grid for the coastal green roof, the better chances are for the designer to develop a green roof planting scheme that will be successful in the long run. There are, in reality, many secondary design variables that can impact a coastal green roof. It's up to the designer to analyze each particular site and develop a list of potential impacts. Sand deposition is a very real potential for coastal green roofs. In addition to salt scourge, wind, and light availability, sand can completely cover a green roof within a matter of weeks. Sand, however, contains many micronutrients, and I always like to add a little bit to the soil media. But sand is unpredictable. You can never block in or block out sand. Sand has a mind of its own, and combined with strong coastal winds, sand can have a definite positive or negative impact on coastal green roofs. Combining all the primary and secondary design variables that the green roof designer has assimilated during site observation, the green roof designer can now come one step closer towards finalizing a successful green roof planting design. Take the plant species list developed from the ginkgo tours and site botanical surveys. Divide the existing native plants found growing on site into C3 plants, C4 plants, and CAM plants, respectively. CAM plants should always be used as perimeter plants on the coastal green roof. C4 plants such as the Asteraceae and the Poaceae, the asters and the grasses, can be interwoven with the CAM plants to serve as perimeter wind and salt breaks, and they can be used as an interior windbreak to protect more sensitive C3 plants. A coastal green roof designer should quickly be able to look at a project site and read nature's patterns. CAM and C4 plants, such as the seashore grasses, will be growing in those areas that C3 plants cannot adapt to. Seashore grasses, because of their C4 photosynthesis, are especially well adapted to frontline wind exposure. Variations in elevation across a site can easily be recognized by the difference in plant biology, responding to different wind impact levels. A green roof designer will recognize the fact that more tender C3 plants are protected and surrounded in nature by C4 and CAM plants. For the successful coastal green roof, the green roof designer must be able to look at a site and differentiate between light availability, wind impacts, and salt scorching potential. Another very important note for the coastal green roof designer is to always follow ASTM and other fire standards. Finally, a coastal green roof with all the challenges can be a very unique work of art, a beautiful masterpiece. The tools are in the hands of the green roof designer. Understand the site, understand the plants, understand the environmental variables, and you're sure to create a long-lasting, successful coastal green roof with native plants.